I'm an old school guy, and up until today I have been using this cool looking vintage Tektronix 2246A from 1989. It's a 100 MHz analog scope with 4 channels, and it still does the job, at least with the stuff I do. A few weeks ago I did a video about the Nabo personal computer, and we ended up doing a minor repair. However, when we tried to get it online, something wouldn't work. And that turned out to be my very first project where the good old tech couldn't help me out. If you're a regular viewer of this channel, you know that I don't really do product reviews. I do, however, like to try out new tools on real vintage computer projects. And what better project for a new scope than the Varda-bombed Commodore PC10? So let's open up that box and play around with my new toy on the seemingly endless Commodore PC10 project. When deciding on what scope to buy, I checked what good old Dave Jones recommends. Well, that's a very large box with a very small scope inside, and that is actually the biggest advantage for me, because very often I don't use my scope when I should, because my old tech is so damn big and I have to put it away after every time I have used it, and it's a bit of a hassle every time I need to bring it out. This scope is so small, it gets to stay on the bench even when I don't use it. Well, my first impression is, damn, that thing is small compared to my tech. It's absolutely tiny. It's quite remarkable what you get for the money, and it even includes no less than 4 probes and a certificate for calibration, but no manual. And it's quite heavy, and it feels really solid, so I think it's a pretty well built scope, and there's probably a reason why it has become so popular. Now let's move to the bench and try it out on the Commodore PC10 project and see if the scope can tell us the age-old question, what's wrong with the Commodore PC10? Okay, so I went on the RIGOL homepage and downloaded Ultrascope remote interface and control on the good old T60. Yeah, it's been a couple of years now since I made the T60 project, and I'm still using it, not as my daily driver, but for stuff like this. So now we can just right-click our RIGOL in the list and click Ultrascope. And for some reason that didn't work. Okay, not sure what that error was about, because the software seems to be working. Okay, let's see how fast it is. So I'll disconnect the lead. And if I put it back on, well, it actually came up immediately. So that's a good start. Now let's see if we can get some measurements on the screen so you can actually see what I'm seeing on the scope. So let's turn on frequency. Nothing happened. Let's try this thing down here. Maybe I should read the manual. Okay, here it is. And I guess voltages could be useful to see too. Let's go with Vmax. Okay, so the test signal from the scope is 3 volts running at 1 kHz. And I don't seem to be able to make this window smaller, so that is taking up quite a lot of space. Okay, I think this is the best we can do. But where is the trigger point? I wonder if I can turn it on here somehow in the software. Okay, so this is really weird. I can change the trigger here in the software, and it does change on the scope, but it doesn't show up here in the software, so you can't see where my trigger point is. Okay, but I think we're ready to make a quick test on the board. Okay, let's start by testing the scope on this working 5150 board. So let's check the basics. So VCC, well, we've got 5 volts, but that wasn't immediate. Let me try that again. That is quite a delay. It takes about 3 seconds. That is very slow. Let's check the reset pin. So I'll turn the machine off and I'll turn it on again. It went high and then low again. But the software is too slow, so it never showed up on the PC. But I could of course see it on the scope. That's not great. That is way too slow. Let's try again. And boot. No, I can't seem to be able to catch the reset. The software sucks. Or perhaps I'm not doing it right. Let's check the address lines. So address line 14. And I can see the signal on the scope, but nothing on the PC. Let me try the auto. Okay. Okay, here we go. Okay, so that is looking good. Let's check one of those weird combined address and data lines. And it takes about 3 seconds before I get the signal on the PC. But here is our signal. So it does work, but it's far from perfect. So let's check the clock on pin 19. And our meter is showing 4.717. So that's good enough, I guess. Well, it's workable, but it's far from ideal. I'm kind of surprised here. I was expecting much better software, so I could show you guys what I'm doing on the scope. Well, this is what we've got, so let's just work with it. Let's bring out the Commodore PC10. Well, I realized my mistake here. The IBM T60 is just too slow for this software.
Made a mistake.
Oh, shut up, Mac. The thought never occurred to me that the software would require a much faster PC. So now I have switched to an i7-6700 with 16 gigs of RAM and a GeForce GTX 950. And hopefully that's enough. I redid the test off camera and the signal showed up on the PC within roughly 1 second. Perhaps a bit less. Now that still isn't fast enough to catch the reset signal every time, but occasionally it will show up on the PC. So at least now we can use it. Okay, so the Commodore PC10. Well, this is a very lengthy project. But very briefly, when I got this Commodore a few years ago, the battery had leaked and caused massive corrosion. So we have removed all the damaged components by first grinding away a layer of the damaged solder, and then using a really good flux and hot air and a desoldering gun. Next we cleaned and tinned all the damaged traces and repaired about a dozen of them. I have only removed components that were visibly damaged and components that were covering corroded traces. Since then I have obviously replaced all the missing components with parts from well-known suppliers and a few new old stock parts from eBay. We have also checked voltages and for shorts on the power rail. A viewer made some diagnostic ROMs for us to try out. Thanks, Greg. So we know that this board tries but fails to complete post. The beep codes that we got indicate that we have some trouble with the base RAM. When we checked, we found some more broken traces, but that still wasn't enough. There is something else wrong with this board. We have also tested the CPU and all logic chips that are in sockets. We replaced the bad socket and we found a trace that was so thin it actually acted as a 100 ohm resistor. That was a first for me for sure. So far we have not been able to get anything on the screen, but I am an optimist, so I have a freshly tested graphics card in the ISA slot today. We checked some signals in the previous video with my good old tech, but I don't quite remember what we saw. So let's start fresh. And I just realized that I still have the diagnostic ROM on the board. So we might as well quickly check that we still have the same fault codes. And sure enough, so I'm gonna quickly replace that EEPROM with the original ROM before we start measuring things. Okay, let's get that ROM out. We better add some deoxit magic in the socket before we put the original ROM back in. And minding the notch. The original PC10 ROM is back in the socket. Okay, let's start with the basics. VCC on pin 40. Let's turn that power on. And the scope is misbehaving, because I'm getting 50 volts. There's no way there's 50 volts on this board. What the heck is going on? Okay, my probe is set to 1x. So that makes total sense. So we will probably find 5 volts now. What the heck is going on here? So first we had 25 volts, and now we're down to 5 volts. But I'm not getting anything on the screen. Let me try the auto mode. Okay, here it is. But it immediately disappeared again. What the heck is going on here? So let me change to 1 volt per division. And I'll put the cursor on this line here. And I realize that you don't see the cursor on the screen. What's going on with this software? Let's try the auto settings on the software and see what we will get. Okay, so here we have the 5 volts. So the changes I'm making on the scope don't show up in the software. That is completely bloody worthless. So I have to use these buttons up here. But at least we're getting 5 volts. Okay, so I did some testing off camera here, and this is what the problem is. I have to set the scope separately and then do the same settings in the software. So they seem to be working completely separate from each other. What a joke. So back to the reset line at pin 21. And I should now have 500 millivolts per division. So let's boot the PC. And I just noticed that we don't have room for 5 volts. So I need to figure out how to change this in software. So when I change to 1 volt per division on the scope, nothing is happening in the software. Okay, so it's down here in the corner. So I have to manually click, and it only changes in incremental steps. This software is hideous. What a joke. Okay, but at least now we have 1 volt per division on the PC. So there's our 5 volt VCC. Okay, so let's try again with the reset pin. I'll turn it off and I'll turn it on. And yes, a bit slow, but it went up to 5 volts briefly and then went low again. So the reset is working. Okay, so let's check the clock. We've got 7.1 megahertz. And I'm getting nothing on the PC. This is completely worthless. So nothing I do on the scope is showing up on the display. Okay, so I managed to get the signal in the software by clicking tons and tons of times on this tiny little arrow. I hope I'm doing something wrong here, because I have a hard time believing that this software is so incredibly bad. Well, at least we have a clock. So let's check one of the data pins. Okay, so let's start with address line 15 up here at pin 39. Hey, check this out. That looks alright. So address line 15 looks good. Okay, let's try A16. Yeah, that looks fine too. Yeah, I don't think we are far off from getting this board running. 17 looks good. 18, 19. Yeah, this is looking really good. 14 and 12, 11, 10, 9 and 8 has a green dot and I don't remember why. But it's fine too. Okay, so now we're moving into the combined address and data lines. So I'm just skipping very quickly from one pin to another, but I don't see anything weird. Well, I'm seeing a lot more on the scope than what you guys can see in the software, but everything looks normal. So we seem to have a partially running system. I couldn't see anything suspicious on any of those pins. And we know that the speaker is okay, so that means it doesn't complete posts. Well, I was expecting that we would find something weird, and then follow that lead. But that CPU seems to be ticking along quite nicely. Well, all the RAM chips are tested, so we know they're good. And we checked all the traces, so we're gonna have to guess here. And it could of course be one of many different things. But we need to pick something. Okay, the next thing I want to try out is the variable speed of the system. So the Commodore PC10 can run at 3 different speeds. And it boots up to 7.16 MHz, as we saw before. But with the key combination, we should be able to change this. So I have connected the original keyboard. So I'm going to press Ctrl-Alt-S for standard speed. And it didn't change. Let's try Ctrl-Alt-D for double speed. Now that should have changed the system to 9.5 MHz. So that only confirms that the post hasn't completed. Well, I just had a look at one of Dave Jones's videos about this software.
It's got fail written all over it. This is horrible. Oh, I think I need to lie down after that software experience. Oh my goodness, I wouldn't wish that on anyone. That is truly awful.
Well, I got the scope directly from RIGOL, so I guess I'll send them an email and ask them if they'll take it back. I don't mind spending some more money and getting a scope that has a proper software. Okay, so one of the main suspects we have are the 74LS245s. So next we're gonna follow that signal from the CPU to the first 74LS245 here. And it's U104. So let's take a look at those pins and see what we get. So I'm just gonna quickly go through all of these pins. But it's not likely that we have a broken trace between the CPU and this chip here. So I don't expect to see any problems here on this side of the chip. And on the other side, signals should come out. And some of those peaks are a bit low, about 3.5 volts. Yeah, they all seem to look like this. So they are very slowly rising. I'm probably skipping ahead here a bit because they all look similar. So back to the schematics. Well, I guess it's more efficient to start at the far end instead. So down here we have bank 0 with OKI 41256s. So let's see if we have some power down here first. We do. Nice and clean 5 volts. So I'll just poke around here and see what these signals look like. That looks good. Yeah. Nothing weird so far. And according to the diagnostic ROMs, this is where we should have our fault. Well, I guess I might as well check all the chips. But I'm gonna skip ahead here. Well, this is where we would expect the fault. But I'm not seeing anything weird. All those pins look normal to me. And if I'm mistaken, you're always welcome to comment. Well, I guess I'll quickly go over all the RAM chips. But then we're gonna have to try something else. Because I'm not seeing any problems with the RAM chips. Well, my good old T60 may not be good enough for RIGOL's crappy software, but I still like it, and so does my TL866. So, next up we are going to burn new BIOS chip. I found a whole bunch of copies of this BIOS online, and according to one forum thread, this file should be working. Okay, so something wrong with this chip. Let's blank check it. It's not the same brand of EEPROM. So let's skip the ID check. And blank check. That's better. Now let's burn the sucker. Okay, let's try it out on the board. So let's pull that original EEPROM out of the board. This is version 4.36. And as always, some deoxit magic in crusty old sockets. Okay, let's see what it does. Well, these things are slow to post, so I'm gonna give it a minute. And unfortunately, it didn't make any difference. Okay, so I had a look in the schematics. And these chips here that are involved in the RAM chips, they were all in the damaged area. So they have all been replaced with new chips. However, if we look further down, this row here, we have a bunch of more chips that are involved in the RAM. And it's these buggers here. And according to a few comments, some of these are prone to fail. So these are now our main suspects. Let's start pulling them out and test them in the chip tester. Okay, let's see how bad the solder is in this area. It definitely doesn't look as bad as in the damaged area, but it does look a bit crusty. So we are definitely going to add some fresh solder before we attempt to remove this chip. This is easy compared to the damaged area. So this solder is melting right away. I don't know much about chemistry, but the battery juice does something with the solder that makes it very hard to melt. Okay, and with a freshly cleaned desoldering gun, because it had clogged up completely. Ooh, what a difference compared to before I cleaned the gun. And I also replaced that small filter inside, so that may have something to do with it. Well, I guess I'll remove a few chips off camera and we'll try them out in the chip tester. Well, fresh solder didn't help, so I had to reflow the chip and it still wouldn't come out. So I'm gonna have to use a rework station because this chip is stuck with some crusty old solder on top of the PCB. So this isn't going to be fun to watch, so I'm gonna skip ahead here. Okay, so I ended up watching IBM Museum's live stream, and while I did, I managed to remove all the chips and solder in sockets. I guess it would have made more sense to pull one chip at a time and test it, but it's kinda nice to watch YouTube and solder. So all the chips are out. Let's try them out with a TL866. So first we have a 74LS244. Let's see if we will find more bad components. And that chip is good. So far we have found 4 dead chips, I think, on this board. Let's see if we will add to that list. So next up is a 74LS245. So I don't really know how good this tester is. So I don't mind if you share your experience with it. And that chip is good too. And that chip is good too. And next up we have a 74LS244. And that's a good chip too. And that chip is good too. Well, at least I got to watch some YouTube. And the last chip is good too. Okay, so those chips were good. And I ran out of time for this week. And also things to try. So I'm not sure what we are going to test next. So put your guesses down below. And when I have a small list of things to try, I will get back to this project once more. I'm a very stubborn guy, so I'm not gonna give up on this Commodore. It may or may not take a few more attempts, but one day we will find the last fault and we'll get this Commodore up and running. And about the scope, well, it's a great scope, so I'm not saying you shouldn't buy it. However, for making YouTube videos, that software is just too crappy and it's not really useful. So I guess I'll try to return it. I would like to end this video by saying a big thanks to my patrons. Your support means a lot to me. And if you want to become a patron too, you will find the link in the description below. And now is a good time to watch one of the previous videos about this project. Thank you for watching, and don't forget to like, subscribe and leave a comment. And I will see you next week.